Now next chapter which we are going to start is that is your functions. Functions is the base of your calculus, and you can say it is the foundation of our calculus. Now calculus is the most important topic as far as the competition is concerned. Its weightage approximately in the competitive exams is roughly it is 20%, and moreover very important here you have to understand the things. If you can understand very well, then obviously you will not have much problem in these chapters. So the first chapter which we are going to start here is that of calculus, is functions. First we need to understand what is the meaning of functions. Now if function f defined from x to y is a rule or collection of rules which associates to each x belonging to x a unique y belonging to y. Frankly telling you, it is very difficult to understand this language if I don't explain to you the meaning of functions here. Now, first of all, how do we say these words? A function f defined from x to y is a rule or collection of rules which associates to each x belonging to x a unique y belonging to y. What do you mean by this? First of all, this x is called the domain of f. This y is called the codomain of the function. So first try to understand the meaning of function. Now this is x set, this is y set. Let us say these are the elements of the x set. Let us say these are the elements of the y set. So to each x belonging to x, let's say corresponding to A, we have the image as 1, corresponding to B it is 2, corresponding to C it is 3. If corresponding to D there is no image in y, then we will say that it is not a function. Corresponding to D, if there is no image in y, then it is not a function. Why? Because by definition to each x belonging to x, since for every x in this case there does not exist y, therefore it is not a function. Now what are the other way outs, or what are the other cases in which it will not represent a function? Now for example, say you have a, B, C, D, 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. Say corresponding to B, the images are 2 and 3. Since they are not unique, you can see that to each x belonging to x is unique y belonging to y. So corresponding to B, it is not unique, so that is why it does not represent a function. So these are the two cases under which this will not represent a function. And in your competitive exams, there has been a question being exactly asked on the basis of these diagrams, or you can say on the basis of the Venn diagrams, whether it represents a function or not. So you should be very clear about this. So if corresponding to D there is no image, it will not represent, since corresponding to D there is no image in y, not a function. Corresponding to B, the image is not unique, so it is not a function here, right? Now next is, what do you mean by domain, and what do you mean by range, and what do you mean by codomain of the function here? Now corresponding to say D, the image is 6. So domain of the function is A, B, C, D. What is range? They are also called the pre-images. They are also known as the pre-images. What is the range? Range is 1, 2, 3, 6. So the images corresponding to the pre-images forms the range. Images corresponding to the pre-images forms the range. So 1, 2, 3, 6 is the range. Now what is codomain? Codomain is 1, 2, 3, 4, 5, 6, 7, 8. So that forms the codomain of the function here, right? So in other way around, domain is the set of all the values of x for which your function is defined. Domain is the set of all the values of x for which the function is defined. What do you mean by this? For example, fx is equal to 1 over x. Can this function be defined for x is equal to 0? No. So denominator should not be equal to 0. Now, for example, fx is equal to root x. Now, since value within the square root should always be positive, can it be defined for the negative values of x? No, it cannot be defined for the negative values of x. So therefore, in the first case, we said that domain is whole of the real line except 0, and in the second case, we say that domain is closed interval 0 to infinity. So this is the domain here, right? So first, along with the functions, we will keep on discussing your domain, range and codomain, but let us start with the topic that is your functions. Now let us discuss some standard functions. The first one is standard functions. Their graphs, domain and range. The first one is constant function. So what is the literal meaning of constant? Which doesn't change. So similarly, the function which doesn't change is called the constant function. Which means if it is independent of the variables, then it's a constant function. So for example, fx is equal to c is called the constant function. Now, what is the graph of this function? If c is positive, it takes value this. Because y is equal to fx is equal to c, so y is equal to c is a line parallel to x-axis at a distance of c units from the origin. Now looking at the graph, you can see that x can take all the values over whole of the real line, but y will take only one single value, that is your c here. So therefore, domain of this function is whole of the real line, range of this function is one particular value c. That is, x can take whole of the real line, but y can take only one single value, that is your c here. So this is the domain and this is the range of the function. Now next is identity function. Now what do you mean by identity function? Fx is equal to x is called the identity function. Fx is equal to x means that y is equal to x is called the identity function. Now you can see here, if we plot the graph of y is equal to x, it is going to be a line passing through the origin, making an angle of 45 degree with the x-axis. Now since x can take all the negative as well as positive values, y can take all the negative as well as positive values, so therefore domain of this function is R, range of this function, that is also R here. Now next is modulus function. So how do we define it? Fx is equal to mod of x is equal to x if x is greater than equal to 0 and is minus x if x is less than 0. This is called the modulus function. Now, is x if x is greater than equal to 0, which means that if I have to plot the graph of this, it will go like this, and is minus x if x is less than 0. So if x takes negative values, when you substitute it here, minus into minus, it will give you the positive value. So this is the graph of the modulus function. So domain of this function is whole of the real line, range of this function. Since whole of the graph is above the x-axis or equal to 0, therefore it is closed interval 0 to infinity. So this is the graph of the modulus function, this is the domain, and this is the range. Now next is your signum function. Fx is equal to mod x over x when x is not equal to 0 and is 0 when x is equal to 0 is called the signum function. So you can see here, if we define this, can I write this as x over x if x is greater than 0? Can I write this minus x over x if x is less than 0 and is 0 when x is equal to 0? So which means that this is equal to 1 when x is positive, minus 1 when x is negative, 0 when x is equal to 0, which means that it can take only 3 values, minus 1, 1 and 0. So therefore domain of this function is whole of the real line, range of this function is minus 1, 0 and 1. It can take only 3 values. So how the graph of signum function is going to be like? So it is 0, 0. So this is 0, 1. This is 0, minus 1. So graph is going to be like this, like this. So that means these two values are not included, but 0, 0 point will be included here. This is included, this is not included, this is not included. So when x is greater than 0, the value is 1. When x is less than 0, the value is minus 1. When x is equal to 0, the value is 0. So this is the graph of the signum function. Now next is greatest integer function. In short, this is also written as GINT function. Now fx is equal to x written in the square brackets is called the greatest integer function, and by definition it is always less than or equal to x. So by definition it is always less than or equal to x. Now what do you mean by this? For example, we want to find the greatest integer function of or value of 1.3. That is, integral part of 1.3 will be what? So on the number line, whatever is the value of x, you look at the value which is integer and to the left of it on the number line. So for example, so this is 0, this is 1, this is 2, this is 3 and so on. Here you have 1.3. Look for the value, integer value, which is to the left of it and nearest integer, and that is your, for example, in case of 1.3, this is 1.3, to the left of it the integer is immediately integer is 1. So integral part of 1.3 is 1. You can see that 1 is always less than 1.3, which satisfies this. For example, so it is 2.9. So 2.9 is here. Immediately to the left of the integer is 2. For example, it is say minus 3.1. So here it is minus 1, minus 2, minus 3, minus 4. Minus 3.1 is here. Immediately to the left of it is, that is your minus 4. If it is the integer itself, let's say x is equal to 2, then integral part of 2 is equal to 2. Right? Integral part of x plus integer is equal to integral part of x plus integer here. So this is the property of the integral part of that is greatest integer function here. Integral part of x plus integer is integral part of x plus the integer here. You can see that whatever is the value of x, when you substitute here, you are always going to get the integer value 1, 2, 2, minus 4 and so on, which clearly shows that the range of this function is only the integers. That is, domain of this function is R, range of this function is only the integers here. Now let's see how the graph of this function is going to behave. Now we have fx is equal to integral part of x. So you can see here is equal to 0 when x belongs to 0 to 1. Left side is closed, right side it has to be open. 1 when x belongs to 1 to 2. It is 2 when x belongs to 2 to 3. It is minus 1 when x belongs to minus 1 to 0. It is minus 2 when x belongs to minus 2 to minus 1 and so on. So if we plot the graph of this is 0 to 1, this value is not included. So this is the line graph here. 1 to 2, this value is not included. 2 to 3, this value is not included. 3 to 4, this value is not included. Minus 1 to 0, it is minus 1. Minus 2 to minus 1, so this is the graph. This is the graph. So you can see here, this is the graph of your greatest integer function. So sometimes it is also called the step function because you can see that steps are being formed here. This is also called that is your step function. Now next is fractional part function. X written in the curly bracket of x is called the fractional part function, and how do we define it? It is x minus integral part of x. So fx is equal to x written in the curly bracket of x is called the fractional part function. Domain of this function is whole of the real line, and range of this function is always between 0 to 1 here. Whenever greatest integer function is there or the greatest function is there, whenever you have to plot the graph or to solve the questions, we have to consider the continuous intervals. For example, x lying in the interval 0 to 1, 1 to 2, 2 to 3, 3 to 4, so on. Similarly on the negative side, minus 1 to 0, minus 2 to minus 1, minus 3 to minus 2 and so on. Now, fx is equal to x minus integral part of x is equal to x when x belongs to 0 to 1. Why it is x? Because we know that when x belongs to 0 to 1, integral part of x is equal to 0. It is x minus 1 when x belongs to 1 to 2. Why it is there? Because you can see that as x belongs to 1 to 2, integral part of x will be equal to 1. So that's why it is x minus 1. It is x plus 1 when x belongs to minus 1 to 0. It is x minus 2 when x belongs to 2 to 3 and so on. So how to plot the graph of this? So this is 0 to 1, 1 to 2, 2 to 3, 3 to 4, minus 1 to 0, minus 2 to minus 1 and so on. So this is the value 0 to 1. When x belongs to 0 to 1, y is equal to x, but it will not take value 1. Why? as x is open, as x belongs to 0 to 1, as y is equal to x, so therefore y also takes value 0 to 1. As x belongs to 1 to 2, x minus 1 will belong to 0 to 1, that is y will belong to 0 to 1, which clearly shows that range of this function is from 0 to 1. So similarly, when x belongs to 1 to 2, graph is like this, graph is like this, graph is like this, so it is like this, it is like this, and so on. These are all parallel lines and they cannot take value 1, but we can take value 0. So that is, domain of this function is whole of the real line, but range of this function is closed interval 0 to open interval 1. Now next is logarithmic function. So how do we define this function? Fx is equal to log of x for all x greater than 0. So whatever is the coefficient of log, that should always be positive, and that gives you the domain of the function. So domain of f is open interval 0 to infinity. Just for example, if I want to find the domain of log of x plus 1 should be greater than 0. That is, x is greater than minus 1. Let's say I want to find the domain of log of x square. I will say that x square is greater than 0. X square greater than 0 implies that it is whole of the real line except 0. Anyway, this way you find the domain of the questions involving log. Now, range of this function is, that is whole of the real line. So how do we plot the graph of this function? You can see here this is 0, 0. This point is 1, 0. Now, this is the graph of, that is your y is equal to log x. So when x belongs to 0 to 1, log x takes negative values. You can see here. This graph is not going to intersect the y-axis, as x is always greater than 0. As x crosses 1, log x takes positive values. So that's why its graph is above the x-axis. So domain of this function is 0 to infinity, and range of this function is whole of the real line. So some of the properties of log of x is, now properties of log function are log of m raised per n is n log m. Second one is log of m into n is log m plus log of n. Third one is log of m over n is equal to log m minus log n. Fourth one is, that is your log of m to the base n is log m upon log n. So in particular, log of any number to the same base is always equal to 1. Then you can have log of x to the base a is equal to b implies, that is log of x to the base a equals to b implies x is equal to a raised per b. Then further, log of e raised per x to the base e is equal to x. Then e raised per log of x to the base e, that is equal to x. So these are some of the properties of log which are going to help you in solving your questions relating regarding log, and it can be in any of the topics. It can be in calculus, it can be in algebra, it can be in trigonometry, it can be anywhere. So these are the properties which are definitely going to be helpful in solving the questions relating to log. Now next is your exponential function. Fx is equal to a raised per x is called the exponential function. Now domain of this function is whole of the real line, but range of this function is open interval 0 to infinity here. Now if a is greater than 1, or you can say that in particular if a is equal to e, because we have already discussed the graph of log of x to the base e, where e is called the exponential constant. So if a is equal to e, that is fx is equal to e raised per x. So how the graph of e raised per x is going to behave? So it is going to be like this. You can see here exactly, you can say it is the mirror image of log of x to the base e. Now domain is whole of the real line, but range is, that is open interval 0 to infinity. It can never be equal to 0, and it can never take, that is e raised per x cannot take the negative values. So this is the graph of the exponential function.